Morning, Elbot here. We're going to go into the next thing of concepts. And the next concept we're going to cover is called molarity. Well, what is molarity, you ask? Well, molarity, as you see in the name, involves a concept we've already been talking about, the mole. Molarity is a big concept we have when we start talking about solutions, basically liquids. And molarity is, here we go. Molarity is how we measure the concentration of chemicals in an aqueous state, basically a solution. Okay, so a question you might have is, what the heck is aqueous? Well, aqueous, if you think of the root word of aqueous, it kind of sounds a lot like aqua. And aqua is, hey, water. So aqueous simply means dissolved in water. Aqueous means dissolved in water. So what's going to be dissolved in water? Well, let's go back to the name. Molarity, mole. So we're going to be talking about moles, measurements of substances dissolved in water. Now, let's go back a second because I use the term solution. Make sure everybody understands what a solution is. A solution is made up of two parts. Okay. The first one is what's called the solute. You might remember that back from middle school. And then the other piece is going to be called the solvent. Okay. Solute gets dissolved. The solvent is the thing that does the dissolving. Now that can be true for anything. It doesn't have to be basically something dissolved in water. If you think about it, I'm going to make chocolate milk. The chocolate milk powder, the solute, gets dissolved in the milk, which would be our solvent. Salt water, we have the salt, the solute dissolved in water, which is the solvent. Okay, it works that same way, and that's what a solution is. Now, the question becomes, what the heck is molarity? Well, molarity has a set formula. And we're going to come back to this time again. There's two different types of problems based on that. We'll get to that in a second. Well, molarity, once again, root word mole, simply equals moles over 1, big thing there, 1 liter. Molarity is moles over 1 liter. And actually, I'll make that an ES for you guys. Okay, molarity is moles over 1 liter. That's what it is. That's the main concept we're working with, of moles over 1 liter. Now, we can convert into and out of moles, so we're going to. Okay, liters, I'm going to show you a way to convert liters. One thing, might as well have you guys copy this down, just because you might see it, is 1 liter. And we know liters, we can break them into smaller things. We do that in lab class, have the graduated cylinders. 1 liter equals 1,000 milliliters, because remember we'd work with like 50 mils of water and all that. We're not going to measure a full liter in class, that would just be silly. Okay. Periodically, you might see a liter also written as a dm cubed. That stands for cubic decimeter. It's the same volume as a liter. So these are the same thing. I try to keep it in liters or milliliters for you guys. Okay, but it's something that periodically you might see. In some of the classes, I know we talked about this. People want to know, okay, milliliters, we don't often hear about that. You're right. Okay, but there is something that you might have heard of. Okay, especially in the medical shows, you might have heard of cc's. Okay, well, a cc stands for a cubic centimeter. Okay, and here's where it kind of comes across. If we have 1 cc, that's the equivalent of 1 milliliter. So if they say it's a 50 cc engine, That means it's a 50 milliliter engine. Okay. When they give somebody 5 cc's of a medicine at the hospital, they're giving them 5 milliliters. Why? Because it's probably easier to say cc. Okay. So you do want to make sure you keep those in mind because you're going to need that information. Okay. Primarily, it's going to be the liters and milliliters, but periodically you might see this. You might see this. Remember, cc is another way to write cubic centimeters. And sorry, the parenthesis got in the wrong spot. There we go. Okay. There are two types of molarity problems. And we're going to actually have 2 different videos on this to show you how to solve these. The first one, calculate molarity using grams or moles, because remember you can take grams and convert it into moles, and a certain volume of water. Now I have to give you a gram value or a mole value, and I have to give you a volume of water. Your job is to set it up like this. That's what it is. Well, easiest way to denote this, and you'll see me do this at times, is this is what I write for the base equation. Capital M equals moles per liters. I generally put a line over it, so I make sure it's not confused with anything else. And moles is over 1 liter. Okay, so you'll see me write this a lot on these problems because you'll see me fill in the blanks. The second type of equation is going to be calculating grams using the molarity, concentration, and the volume of the solution. So if I know I have so much of this and I know it's got this certain level of concentration, I'm going to be able to figure out how many moles or how many grams were in that. So if I needed to make more, I could. So that's what we're moving into. Just want to give you a heads up and more to follow.